Today we get to learn about Archimedes' principle. Before we do that, we're going to go back and review just for a second density and what we know about density already, because the two things are related. Density is the amount of stuff in a certain amount of space, or how tightly packed together particles are in an object. In science, we say that it's the mass in a given volume. In fact, we have a mathematical formula, and it is mass divided by volume. Mass is measured in grams, usually using a triple beam balance, and volume is measured in cubic centimeters. Once you have the mass and the volume, you divide the mass by the volume and you end up with density. Density is measured in grams per cubic centimeter, or the amount of mass or stuff in the amount of space or volume. If I wanted to determine the density of these two cubes, I would need to know both the mass and the volume of both. Now, what I know is that the volume of these are identical. They take up the same amount of space. What I also know, and you may not be able to tell, is that this block of copper is much heavier or has more mass than this block of aluminum. So I already know that the copper is much more dense than the aluminum because they take up the same amount of space, and density is really a comparison of the mass and the volume of an object. So if I wanted to find the density of both of these blocks, I would put them on a triple beam balance and find their mass, and then I would use a ruler and measure in centimeters the length times the width times the height to find the volume. I would divide the two, and what I would find is that copper has a density of 8.96 grams per cubic centimeter, while aluminum has a density of 2.7 grams per cubic centimeter. It's quite different. All metals have different densities. Gold does not have the same density as copper. Copper doesn't have the same density as aluminum. Silver has a different density than all of those. And Archimedes knew this. Archimedes knew that all metals had different densities. So the weight of a metal and the volume of the metal would have to match up to the density of that particular metal. He was given a task by King Huron, and that was that King Huron had given a certain amount of gold. He had weighed it and given this gold to a goldsmith and told the goldsmith to make a crown, the crown of Syracuse. And he did, and returned it to the king. And it weighed the same amount, but it had a slightly different color. And so the king was concerned that he had been cheated, that some of the gold had been removed and replaced with a cheaper metal before the crown was returned to him. But he had no way to figure this out, so he went to Archimedes, who was a mathematician. And he asked Archimedes to figure out if the goldsmith had indeed stolen some of the gold. But Archimedes was stumped because he knew how to find density. He knew that he could find the mass of the gold and the volume if it was in a cube, but it wasn't in a cube, it was in a crown. And he didn't know how to figure out the volume of an irregularly shaped object. And at some point, the story goes, that he got into a bathtub, and when he sat in the bathtub and the water went up, he realized that the amount of his body that was submerged in the water was equal to the amount of water that rose. And this allowed him to figure out that we could use water displacement to find the volume of irregularly shaped objects. So we have him to thank for that. But it also led him to developing Archimedes' Principle. And that's what we're really here to discuss today. So I'm going to read to you Archimedes' Principle, and then we're going to break it down. Archimedes' Principle states, the buoyant force acting on an object is equal to the weight of the fluid displaced by the object. That's a whole lot of science. So we're going to break it down. First of all, you need to know what buoyant force is. Buoyant force is the force that acts in an upward direction against the force of gravity to make an object feel lighter. And because it's force, we measure it in science in something called newtons, but you could also measure it in pounds. So you might have 5 pounds of force pushing upward on an object. If it's pushing upward against the force of gravity, then that's considered a buoyant force. The other thing we need to take a look at in here is the word fluid. A fluid is anything that flows easily from one place to another, so it can be a liquid or a gas. So what Archimedes' principle says is that the amount of fluid that's displaced by an object can be weighed, and that weight is equal to the force that's pushing upward on the object. I'm going to give you an example, and hopefully this will help. If you have a pool and it's filled with water, and you take a beach ball and you throw the beach ball in the water, the beach ball is very light, it's not very dense. So it's going to sit mostly on the surface of the water. There's only going to be a tiny bit of water displaced by that beach ball, just a little bit. So the amount of beach ball that's submerged in the water is equal to the water that's displaced. If you could weigh this amount of water, that is the buoyant force that's acting on the beach ball. If you take something and throw it in the pool and it sinks, for instance, say that you drop a cinder block into the pool. This cinder block actually displaces the same amount of water that it takes up. So all of this water would be weighed, and that's the buoyant force that's acting on the cinder block. There's still buoyant force even though the cinder block actually sinks to the bottom. Now, here's the interesting thing. If an object's buoyant force is greater than the weight of the object, it floats. If it's less than the weight of the object, it sinks. So for instance, if this is your water and you have a beach ball, and we're going to use pounds because it's something we're familiar with. Say that this beach ball actually weighs 0.2 pounds. It's very light. It's probably much lighter than that, actually. And it displaces this much water. This much water, if we weigh it, is going to weigh 1.06 pounds. I'm making up these numbers just as an example. Because the water weighs more than the beach ball is going to stay afloat. If we go back to that cinder block, the cinder block is going to sink. And the cinder block may weigh 15 pounds, but the water it displaces is 12 pounds. So it's going to sink. And this all goes back to density. So we have buoyant force acting upward against the force of gravity to make objects feel lighter, and we can figure out that buoyant force by measuring the weight of the fluid that's being displaced. In this case, I used water, but it could have been air or whatever fluid it happens to be in. That's what Archimedes' principle says, but it also connects to density and why things sink and why things float. Hopefully that makes sense to you.